Welcome to Module 2, Lesson 3 on Designing for Complexity. Today we'll explore how to move beyond linear research designs to embrace adaptive approaches that match the complexity of real-world problems. This represents a fundamental shift in how we think about research methodology in transdisciplinary contexts. Let's begin with our learning objectives. First, you'll master adaptive design, shifting from rigid linear protocols to flexible, responsive research approaches. Second, complexity matching, learning to align your design sophistication with your problem's inherent complexity. Third, multi-method coherence, creating integrated designs where different methods work synergistically. Finally, emergent frameworks, building research structures that evolve as you discover more about your phenomenon. The research design complexity spectrum helps us understand that not all problems require the same approach. Simple problems with clear cause-effect relationships work well with linear designs. Complicated problems with many knowable parts benefit from sequential analytical approaches. Complex problems where patterns emerge through interaction require adaptive, emergent designs, and chaotic situations with no clear patterns demand rapid, responsive crisis designs. The key is matching your design to your problem's complexity, not defaulting to your comfort zone. Complex adaptive research design is built on 4 core principles. First, embrace uncertainty by designing for discovery, not just confirmation. Second, implement iterative refinement through cycles of data collection, analysis, and design modification. Third, integrate multiple perspectives from diverse viewpoints and methods. Fourth, focus on emergent patterns that arise from the data rather than imposing predetermined structures. These principles work together in an adaptive research cycle, moving through design, data collection, analysis, reflection, stakeholder input, and refinement phases. Multi-method coherence ensures your diverse methods work together synergistically. This requires philosophical alignment, where methods share compatible assumptions, complementary strengths, where each method addresses others' limitations, integrated analysis, where data streams inform each other throughout, temporal coordination to maximize cross-method insights, and a unified theoretical framework guiding all methods. For example, in health equity research, combining survey data, community stories, and photo voice creates comprehensive understanding of both barriers and lived experiences. Validity concepts differ across paradigms, but can be integrated in transdisciplinary research. Positivist paradigms emphasize internal, external, construct, and statistical validity. Interpretivist paradigms focus on credibility, transferability, dependability, and confirmability. Critical and transformative paradigms prioritize catalytic, democratic, process, and outcome validity. Transdisciplinary research honors all these validity frameworks using criteria appropriate to each method while creating meta-validity spanning paradigms. Emergent and responsive design features living protocols that evolve based on findings. Progressive focusing that starts broad, then narrows based on patterns. Rapid cycle learning through short iterations. Stakeholder responsiveness incorporating feedback into design decisions, and real-time adaptation modifying methods based on contextual changes. The process flows from initial broad exploration through preliminary data collection, stakeholder consultation, refined focus, deeper investigation, and validation through member checking, with continuous feedback loops at every stage. The design decision framework helps you make strategic choices by considering 4 key dimensions. First, assess your problem's nature. Is it well defined, exploratory, or wicked? Second, evaluate your evidence base. Extensive, emerging, or sparse. Third, identify your stakeholders. Academic, practice, or community. Fourth, consider your timeline. Extended, moderate, or rapid. These dimensions guide you toward appropriate design choices from linear to adaptive, confirmatory to exploratory, traditional to participatory, and comprehensive to agile approaches. Common pitfalls in complex design include methods mismatch where simple designs are used for complex problems. Solve this by matching design complexity to problem complexity. Paradigm paralysis, getting stuck in philosophical debates. Adopt a pragmatic approach focused on your questions. Kitchen sink syndrome, adding every possible method. Ensure each method has clear purpose and connection. Premature convergence, locking into rigid design too early. Build in exploration phases. Stakeholder disconnect, designing in isolation. Co-design from the start. Analysis, overwhelm collecting data without integration plans. Plan integration points up front. Your next steps are 5-fold. First, map your problem to identify its complexity level using the framework we've discussed. Second, match your design approach to your problem's complexity. Third, create an integration plan mapping how different methods will work together coherently. Fourth, pilot and adapt by testing your design and building in adaptation points. Fifth, engage and iterate by sharing with stakeholders and refining based on collective wisdom. Remember, the art of research design lies not in rigid adherence to methods, but in the creative adaptation to complexity.